So for this problem, we're going to look at several more of the double angle formula and how we can integrate those, use those and integrate. So the first one is quite nice and simple. For part A, I want the integral of cos squared x minus sine squared x with respect to x. Well, looking at our double angle formula, we have a direct identity for that. Cos squared x minus sine squared x is equal to cos 2x. So we can substitute that in, so we really are integrating cos 2x with respect to x. The integral of cos is sine, so you've got sine 2x, divide it by the differential of the 2x, so we divide it by 2, and because it's an indefinite integral we also need our plus c. A slight modification to that to go to cos squared 3x minus sine squared 3x. Well, we're replacing the x here with 3x, and if we're multiplying by 2 there, 3x times 2 is 6x. So really, we are integrating cos of 6x with respect to x. The integral of cos, again, is sine. So we have sine of 6x divided by the differential of the 6x, which is 6. And again, it's an indefinite integral, so we need our plus c. For part C, we have the integral of 2 sine x cos x with respect to x. Well, this is a different identity. We're now going to look at the double angle sine 2x, which is equal to 2 sine x cos x. And again, we've got a direct replacement there. So we're really integrating sine 2x with respect to x. The integral of sine is minus cos. So you have minus cos of 2x. You divide it by the differential of the 2x, so we divide it by 2. And again, plus c. And the final one then is the integral of 2 sine 4x cos 4x. So that's a slight modification from the last one. And again, we're using the top identity. We're going from x to 4x. So we're timesing by 4 there. So the 2x times by 4. So we're looking at sine of 8x. So the integral of sine 8x with respect to x. Again, integrating sine gets us minus cos of 8x. Divided by the differential of the 8x, which is 8. And remembering our constant of integration at the end, plus c. So that's how you do those 4 integrals using the double angle formula.